Okay, sorry. Okay. You may know you can go to epilepsyecosystem.org. Can you see my screen? Can you just confirm if you can see my screen? Okay, perfect. Thank you. Thank you. Yes, this is like a crowdsourcing for improving the performance of seizure prediction algorithms in order to make seizure prediction a viable treatment option for those suffering from epilepsy. So we have already launched two different data sets. If you go to on how it works, you can get access to this data set, but you have to register and gain access under the terms and condition, which is specified through how it works links. The previous one, which most of you have already developed your, or you want to develop your machine learning algorithm, is available or accessible through the first link. And then we recently launched the My Seizure Gauge data for non-invasive wearables-based seizure prediction. Yeah, it's a little bit refreshment about epilepsy ecosystem. So let's start for today. I am going to, I don't know, we have already announced about the code evaluation instruction on GitHub. Just want to make sure if all of you have access to this GitHub code evaluation instruction, because I'm gonna walk through all these different instruction and explain how you have to prepare your code based on this evaluation code evaluation instruction. So anybody has any issue with getting access to this GitHub, or you can, all of you have already access? Okay. So as you can see, we have two main folder, which one is code evaluation instruction, and the other one about the Singularity tutorial, which I will go on each folder and explain you what you have to do and how you have to prepare your code for us. So first, let's go to code evaluation instruction. So, okay, we have like almost 12 dot points that you have to follow them. So in the first part, so you have to prepare a setting JSON file. So which I put all of the necessary documents and files and folders for you here on the same folder for code evaluation. So in the first part, we ask you to prepare a setting.json file. So, and the reason for that, because we are receiving so many of your algorithm and your code. So in order to evaluate on our full trial system, we need to minimize overhead and getting involved within your code. So you have to stick to this instruction. So let's look at the setting JSON. As you can see, we ask you to define these control variables, which is called run and contest data, which switch between consent data and then full trial data set, which you don't have access, but you have to prepare your code in order to be able to read in both different data sets. And then we ask you to prepare and have like another control variable, which is mode, and I will explain later. Patient index, which in contest data, we have already 3 patients, yes? And as a matter of fact, you don't really need to use this patient index when you are working with your contest data. But for the continuous data, or let's say for full trial, we have 15 patients, and then you have to use this patient index within your setting JSON file. And then you have to use subtract mean, and then we have model, we have this model feed and CSV. Okay, so let's go to the setting JSON file. As you can see, totally we have 8 variables. As I said, the first one is run on contest data. If you set on 1, that means you are playing with contest data, which you have already get access to this data set, including these 3 patients. Mode 3, mode has 3 different, it can get 3 different values of 1, 2, 3. 1 is for training. Depends. If you work on your contest data, you only have 2 modes, which is mode 1 and mode 3. Mode 1 is for training mode, and mode 3 is for test. But when you switch to continuous data, or let's say full trial, and you set this run on contest data on 0, you have like 3 mode. Mode 1, again training, mode 2 for validation, and then mode 3 for test. And then you have like this other variable, as I said, path, which really you don't need to use it for contest data, but you have to set it for continuous data, which the patient indexes ranges from 1 to 15. And then you have subtract mean between 0 and 1, and then you have your model, which is a folder, and you can save your train model in this folder. And then you have another folder which is called feed, which is the intermediate folder. If you want, you can, if you want to do any, I don't know, further feature analysis, you can store your extracted feature in this folder. I will show you how you have to prepare your code and how you can store your extracted feature here, but it is not, but this is only just for yourself, because we are gonna we want to check the performance of your algorithm even during feature training and feature extraction. And you cannot only extracted your feature once and then use it many times. And then we have another folder which is called a CSV. I will tell you what you have to include in this folder, and the other one is solutions, where you save your solution files in this folder. So this is about setting JSON. You have to prepare this this JSON file with all these control variables. Let's move to the next part, which is part 2, but I have already explained. So have the option to run the code on the contest or the continuous long term, as I said. So if you set it on 1, it's contest. If 0, it's like continuous. So you can set it through this setting JSON file. Then, as I said again, you have these 3 data set modes, which is specified by this call variable mode in your JSON file. And as I said, if your mode And as I said, if your mode I just want to make sure that you can hear me. Can you confirm if you are still with me? Okay, awesome. Okay, awesome. And if I go fast, please let me know. So I will go a little bit slower. Okay, so for these three data set modes, as I said, depends on which data set you want to switch. If it's for contest data, if it's for contest data, if it's for contest data, you have to switch between mode 1 and mode 3. As I explained, mode 1 is a train and output train solution, and mode 3 is for test. But mode 2 is just for validation, which you can use, which you have to use, not you can use, for the full trial data. Okay, there is a note about the 10-minute data segment, which is the format or the shape is different between contest data and continuous data. We have already shared just two sample of like .mat file from the full trial data set, which you can get access from these CSV files. If you go to CSV files, and if you go to this mat files folder, you can get access to this to sample of .mat files. And we have already explained how they are different from each other. In terms of their sampling rate. And two important things that you have to be cautious about them is be efficient such that the time taken to classify a 10-minute data segment is at most 30 seconds. And this duration needs to include all feature calculation. That's why you cannot calculate or do your feature like separately and then just import as a input to the rest of your code. And classification is step of pre-trained algorithm. And later, the way that we evaluate your algorithm is using a SAC command on our SLARM job queue system. In order to determine the total runtime for your job and divide by the total number of files processed to obtain estimates of time taken to classify. And the other more important things that you have to be cautious is about utilizing at most 100 megabyte of RAM when classifying a 10-minute data segment. So you have to address this point also when you are implementing your code. Point 7 and point 8 only you only use when you want to play with the continuous data set, which in this case your run on contest data in your setting JSON file is 0. As I said, it's about switching between 0 and 1 for subtract mean, and also for your patient index. Because I will explain why you are not going to use this patient index in your contest data. And part 9 is about how you have to read your actually data set, I mean .mat files, but through this given CSV file. So you have to make sure, let me open this one. maybe this is, oh, here. So if you open this CSV file, so if you see my screen, so you would see all of the .mat file for all three patients in contest data are in this file. So what we want you to do is read those .mat file from this CSV file. We haven't yet included any path here, but and you don't need to worry, but you have to implement your code in a way that when we add like a specified path in our server into this CSV file, it still can read this CSV file and get access to this .mat file. And then the same for, this is for contest data, the same for continuous data. And you can find some example of like train, test, and validation for continuous data. For example, here, if you go, for example, to one, I don't know, train, so you can see, for example, you have again to implement your code in order to read this .mat file from this CSV file, but we will include later our path in our supercomputer in here, okay? So your code should be able to load .mat file through this CSV file. Yes. So this is the way that you have to read .mat files through the given CSV file. I will go through all of them again. And the other thing is that about your solution file. Okay. First, let me come here. So as I said, you have a folder which is called a feature, and you can create some subfolder within this format in order to save your extracted feature if you want. Okay, so this is optional, and as I said, as we are gonna evaluate your algorithm based on your feature extraction and your training model, you cannot use once this feature extraction in your code. And about your solution file, again, for contest data, we have already given you a format of how you can store your solution files. As you can see, this is the given format for continuous data, and this is for contest data. Yes, so you have to store for contest data. So you have three patients. You have to be able to, you have to give us one solution file within this format, including all different, I mean, all these three patients. But for the continuous data for each patient, you are giving one solution file within this format. Somehow within this naming format of your CSV. And then for contest solution, you have to follow the given template here in the CSV file. Okay. Somehow this is a summary of this code evaluation instruction, but I'm going to show you some example. So you have already seen the setting.json, how you have to set up, and then you have to create this folder CSV features model solutions. Then you can give the path to this CSV through your through the setting. Okay, so in this CSV, we have already given you that you have to put all these CSV files within this CSV folder. So totally we have for contest data, we have these contest test data labels public, and then we have contest train data labels. As I said, if you open contest train data, sorry, my internet is a little bit low. As you can see, the format is like you have two columns, image and class, and then you would read the data from here. And then the other thing that you have to make sure for your solution file, you have to give us the solution file in order. And then one difference between .mat file from contest data and continuous data is that in contest data you can get the label from end of the file. As you can see, for example, this is 0. So unfortunately, I don't know. So we don't have. Okay, 0 and 1 for representing pre-ictal and intra-ictal classes, but in continuous data, you cannot get this label from the name of your .mat file. You have to get through the provided CSV file from the column of class. This is another thing that you have to bear in your mind. And then all of these, as you can see, we have already given you a sample of this test and train and validation files for your continuous data, which is totally 45 15 files for each mode, and then you have to be able to read all of these CSV file through your code. Okay, so you have to follow these instructions. So you have to put all of this CSV file in this folder of CSV, as I have already put here. And then, as I said, you can have a folder called feature, and then for continuous data, you have to follow this format. For example, fit data set. 0 means continuous data, and give the path, patient index, and then subtract, for example, if it's 0 or if it's 1. And then you only have one somehow subfolder for contest data, which includes, for example, your extracted feature for 3 different modes. This is how you have to prepare this one. And then in model, you can save your train model here in the folder of model. And I have already explained about solution, and again, you have to follow based on this given CSV file contest solution file in order to prepare your solution file. which here we have like 2-column image, which is the name of your file, and the class, which here you have to give the prediction probability of your files here for us. And then you have to stick to this naming format. This is one example on how you can name your solution file for continuous data. And this is one example on how you can name your solution file for contest data. And I put example of like contest data, continuous data, just a few sample. If you go to contest data, for example, for patient 1 and patient 1, train and test. Again, if you look at here, okay, it's better. Here you can get access to this labeling at the end of your .mat file, which is 1 and 0 for prectal and intrictal. And this is, sorry, this is for your test. This is few sample .mat file for test of your code if you want, but you have already access to this full data set. And then the other one is continuous data, which, as I show you, you have to stick to this format because all of the .mat files is in within this format, which is UTC underscore hour, minute, and second, and then .mat file. And then, as you can see, you cannot get the label from .mat file as you could from .mat file from contest data. Any question?
May I ask one question?
Yeah, sure.
Yeah. For continuous data, how
Sorry, for continuous data? So you don't need to worry about this. So we only give the only way that you have to prepare your code is to be able to read through the given CSV file. Okay. Based on the given naming format of .mat file, because when we want to evaluate your algorithm, so we put the path on our supercomputer on the CSV file, and it will go and directly find us those .mat file. And then you have to define the patient index within your setting.json, which ranges between 1 to 50. Yes? Oh, okay, no worries. Yes, this is actually the first part of our webinar. So any other question? Any doubt?
I have 2 more questions.
Yes, sure.
In the documentation, you say that the Python has to be in a comma. Is that really true?
Yes.
I don't see the point when you provide the images. It has to be underlined.
So I think one reason to be consistent is because when you are using different modules and packages within, for example, Python 3, might be it affects on the performance of your algorithm.
Okay. And another question, you also wrote that we have to take account of the megabytes per each just knowing the model and the values from the that means that the levels
About this 100 megabyte, to be honest, I'm not sure, but you have to, I don't know, I cannot answer why 100, but I could say you have to stick to this 100 megabyte.
okay. So it's not the, so it's the memory that our program needs.
For when classifying a 10-minute, just a 10-minute data segment.
Trying to make it from the time to classify from the time to train. But still, the best way to do it is something that is the start of the maximum amount of range for your job. Yeah. Just given all the other variables. And then it's being recognized. Yeah, it's not. Obviously, people are not going to take the right practice because if you think about it, you're trying to make it easier. That's not going to be a practice. It's not going to be if it can't do that, then it can have it on the front.
No. Any other question on this part? Okay, so this is the first part. Now let's move to the second part, which is about you have to prepare your Singularity recipe. I'm not sure how many of you are familiar with containerizing your code, but just a summary. We are using like a Singularity because it's has already been installed on our supercomputer, and it's some sort of kind of similar to Docker. So, and the reason that you have to prepare and give us this Singularity recipe is that it's much easier for us to run your code regardless of dependency of your codes and other stuff. Somehow, in a very simple way, so you somehow you containerize all of the dependency of your code within this Singularity recipe and let's say image. And we can easily run over our server. That's the reason. But how you have to prepare it? So the easiest way that I've found is working with the Singularity Hub. which if you can prepare just your Singularity recipe, you can easily get your Singularity image from Singularity Hub. Somehow there are like two main steps. The first part is you have to create your Singularity recipe based on your code dependencies, libraries, packages. And after that, when you create your recipe, you have to build your image through Singularity Hub, which I show you how you can do it, and then send the URX of your Singularity and also your Singularity recipe to us. So as a summary, this Singularity recipe somehow has two sections, header and section. In the header, so the header should be written at the top of the recipe file. So you can write it in any like notepad or anything like this, and it tells Singularity about the base operating system that it should use to build the container or your image. And the only keyword that is required for every type of build is bootstrap. And then you have to make sure from which bootstrap you are trying to bootstrap your image. So I have already put the preferred bootstrap agents here, which could be library, Docker, or shop for Singularity Hub, for Docker Hub, and for the container library. So this is just an example of how you can prepare your Singularity recipe, but I will walk through a running example, which I have already put it here, and I think you can get access, and this is the code. So for example, if you go to this code, if you see this code, you can see all the dependencies for this code, and also for the model, and then you can prepare or you can write your recipe based on the dependency of your code like this. So you have to prepare this one, and then you have to when you want to one thing that is important if you want to work with the Singularity Hub, when you want to work with Singularity Hub, is the way that you save this recipe file should be in this format, Singularity dot or dot star, like this format. Otherwise, it cannot run it for you guys. So I have already given the instruction step by step how you can run it over the Singularity Hub. I will go through this step, but I will show you the real example. So the first step, I assume all of you have GitHub repository. You have to connect your GitHub repository to this Singularity Hub. As soon as you upload your recipe, it will automatically, their agent automatically detect your recipe, and you can add to the list of your container, and then you can easily run and build your container through Singularity Hub. So you can get access to the Singularity Hub through this address or through this link, and then this is the Singularity Hub. And then if you go to the collection, and if you go to the collection new, after actually pulling your recipe into your GitHub and connecting your GitHub to this Singularity Hub, you can find a list of your recipe files, which you have already built images for them, like this. And then if you go to this collection, because there is two options, I will show you on the real Singularity Hub. So you can go to your My Collection or New Collection. If you go to my collection, you would see a list of your already built container. But if you want to add a new collection, you can click on this add collection, or you can directly go to this new collection, and you will find a list of a new collection like here. Okay, and then I don't know, you can select your new container, and then you only need to drag this bottom, and then it will change to this blue color, and then you can submit it. But before building your Singularity, just make sure you go to the setting option. I will show you on the here, and then make sure you choose this Singularity builder, because some of them, for example, but the default one is Singularity builder to 500 GB private, but it doesn't support the bootstrap. So just make sure that you choose the right one, as I highlighted here. And then when you go back to this page, here, if you press this reload button or just refresh your web page, you would see that your recipe is in the status of running. And if you get any issue, it will show you like some error, then you have to fix it. Otherwise, if everything goes well, you would get to this part, and then you can get this complete, I mean the running status, change to the complete status, which is green. And then here you can get the URI of your container or your image, and then you have to submit this URI to us along with your original recipe. If you make any changes in this recipe in your GitHub, it will automatically build again this image for you. In order to avoid this one, you can, because here, if you can see, it's like a lock, you can unlock, you can lock it, and then it wouldn't write anything on top of this image, even if you make any changes there. So, and here is my email address that you have to send your URI. So let me show you just a running example. Okay, so suppose you connected your GitHub and Singularity Hub. You can, I'm gonna create a new repository, like so I'm uploading all my code and the Singularity recipe, the setting all together. Okay, as you can see, so I have like pull all of my code along with my Singularity recipe here. So if I go to it's still running. Okay, this is my Singularity Hub. If I go to my collection, as I told you, if you go, I was running something, but that should be fine. And just one more thing, don't forget, I think every day you can only limited to build 10 images. So as I said, you can see a list of your already built images or container here. But if you want to add a new collection, either you can go to this add collection, or you can come here, go to the new collection, and you can find here, for example, this is the one that I just pull on my GitHub. You can press it, you can submit it, and then you have to go to the setting. And then, as I said, please make sure choose the right one. And then if you go back here, so you can see it changed, the status changed to the running mode. Sometimes it takes like, I don't know, maybe depends on your Singularity recipe, might take like 1 hour, I don't know, depends. And then after that, you can like, let me show you, oh sorry. You can, for example, from here, you can pull your Singularity, and as you can see, I just locked this one. So if I modify anything on my GitHub on this part, it wouldn't overwrite on this image. And this is the URL, as I said, that you have to send to us. Okay, let me show you how we are gonna use this URL and your recipe file in order to run your code. So, can you still see my screen? Can you see my terminal? Can you just confirm?
No.
No?
I think you should.
Okay. So what about now? Can you see? Can you see
Yes.
my? Oh, okay, awesome.
Yes.
Awesome. Okay, so first of all, maybe you want to try on your supercomputer server, so you can easily pull this Singularity. So, for example, in our server, we have to load this a few lines of command, and then in order to pull this Singularity, you can easily use Singularity, pull, shove, and then this is the URL of your container, your image in Singularity Hub. But I have already pulled it on our server, so I don't want to do it again, but you should be able to do it easily. Of course, if you have installed Singularity on your server. And then I am binding two directories where my data set and my code are on the server. And then sorry, I forgot to show you. And as you can see here, I execute like the Singularity, and I'm binding. And this is when you pull the Singularity, I mean your container, you would get this .zip file. And then somehow you are rerunning your code within this container. So okay, so if I run this one, it might take a little bit time, but as you can see, it's in the running mode, and it's very easy. I don't need to worried about the dependency of your code. That's why we need you guys to give us your recipe file and the image through the URI. So here, that's all about this webinar. So do you have any question about this second part? Any question? Levin, do you want to add anything, or? So any question?
Yeah, I want to ask.
Okay. Yes, sure.
No, so we need the URI and the recipe file, right?
Yes. That
So why do you need the recipe file for? Just for making it, right? So
yeah, actually it's just for our record.
okay.
Yes.
Okay.
And because I put the email address that you have to send your URI at the bottom of the instruction.
Okay. And if you want to test it like our platform, the container to test it.
Sorry, I couldn't hear you. Can you repeat it again? I'm sorry. Can you say it again? Sorry, I couldn't hear you. Oh, I think. So any other question? Okay. Yeah. Yeah, it seems. Okay, sure.
Yes, the one hope is that we can do some evaluations by the end of the year. So that's the only thing we're going to start looking for some structure of the brain. And then that's the critical program. And then they start testing the cortex stuff. And then we're taking
And we can have some metal codes on that.
it's not fully structured. We haven't run anyone properly. Maybe take care of that on their own. Maybe not pay for
And sorry, I just forgot to tell you that I have already modified Sheng's code, which the original one, which the original code you can find through in the folder of Singularity tutorial, but I modified this code to be able to read this .math file through CSV, create solution file, switch between context and continuous data, and I put both codes in the code evaluation instruction under the name of feature context continuous.pov and then model context continuous.pov.
So that's the code for the second place that we turned into Python 3 code. So we chose that out because it was the fastest way to implement it. In the independent evaluation for the original patients. Could have just taken that around we've got singularity containers. It's very motivating for the people developing the algorithms, but it'll be hopefully smoother. That's into it basically. And we use it as a starting point for the different
Yeah, I still modify a little bit more, but overall it should be fine because I just try to follow all the code instruction in this code. It's just a sample actually, not, and it is not optimized. It's not the best code, but just a sample to show how you can follow all these given instruction.
Okay. All right, now I'm feeling this boring, so
Oh, here he's. Yeah.
all right, continue running from the
Sorry, what else?
No, that's.
yeah, so I had
Ah, you mean on your computer, not your supercomputer. I think you can install Singularity on your computer. Yeah, but yeah, because the only way that you can run your image with, I mean your code within your container is to install Singularity on your system. Yeah. I can, if you want, I can find how you can run it, how you can install it, the documentation, but I would appreciate if you can email me and remind me, then I can find the documentation and I can share with you.
No, I know how to do it. That's what I'm
Ah, okay.
If you everything, I mean, the settings that
Yes, yes. If you install Singularity on your own computer, yes, and you can try and you can test it. Should be fine. Because then you have like a root privilege access on your computer, which we don't have on the server. So, any other question? I think, Levin, I think nobody has any other question. Yes.
have a question.
Yes, sure.
Right now we're using a Singularity timers or just like Sorry.
Yes, you have to stick to the Python because when I want to somehow evaluate your code through your container on the server, I still have to to load the Python modules within this container.
Yeah. Okay. Thank you.
No worries. And we want everything to be consistent in terms of when we want to evaluate your code. So.
So what are the evaluation metrics that we use to evaluate something like
Prediction probability? I'm not
so I'm going to do it like question.
You mean for the for each patient? Yeah, I think it still should be patient independent.
Okay.
Yeah.
Thanks.
No worries.
It's the same evaluation metrics in the brain. 2018 brain ecosystem paper. So AUC and then sensitivity versus target area. And then also target area. So the more important measures are clinically relevant ones. But we don't do that in the contrast database.
So any other question?
Can I just ask? So when we check it, give us an answer if you have it much better.
Yes.
Like in a short time, just like maybe some questions.
Uh, you mean if I can like pull your image and run your code, not evaluating on the full data set? I do my best to answer you as soon as possible. Yes.
At the moment, it's first in, first out, pretty much. But hopefully, ideally, something can be something jumps in parallel. But also, it's that because we need to verify that we can both train. So one of the things that we need to focus I just use to train models that people quote. Because I'm going to have a parallel
Thank you, guys. Thank you. See you. Bye. So let me, because I put it on panel too. So now I have to stop it. Yes. Let's